Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thanks for this sharing sessions regarding GMMs, but GMM related to dynamic panel modeling. Sebab itulah saya tulis dynamic panel modeling. So what I would do, mungkin dalam masa sejam setengah, 1.5 hours, to go through the basic first, right? And then if you have queries, for example, in terms on how to do using Stata, then we shift to Stata, because Stata in my laptops, so we have to shift the from PowerPoint to laptops, right? In terms of Stata. But the most important part, we have to understand the statistic or econometrics behind dynamic panel modeling. So I will go into detail of giving you that understanding, what exactly GMM means, right? And what are things that we need to pay attention when we apply GMMs, right? And of course, it will not include yet interpretation of the result and so on. That require the other 4 hours, for example, to look into the way we should interpret the results when you get the result from GMM or any other econometrics technique that you use, right? So the contents of my presentations, the next slide would be in terms of the contents. I will look into give you introduction first, and then discuss model specifications, and then explain in more details what it means by GMM estimations of dynamic panels. And then I will discuss model diagnostics. And then we can open up and discuss issues when we perform analysis using dynamic panel models, right? Now, in terms of the introductions, which is on the next slide, right? When we perform data analysis using econometrics, we have to go through steps. And these steps that I have mentioned is very important step that whatever modeling that you do, you have to go through these steps, right? You have to go through these steps. And these steps are statement of hypothesis. When you do research in your thesis or in your articles that you want to send for publications, you must have hypothesis stated, right? Explicitly or imply that these are your research hypotheses. Normally, you state your hypothesis in your objective, right? And when we do data analysis, remember, always you would like to look at the linkage between variables. And that's why you have dependent variables and you have independent variables. You want to explain the dependent variables, the behavior of dependent variables, right? Why it move up, why it come down, what are the reasons behind that. So you use another dependent variables. So econometric involves that relationship that you would like to look at. But that relationships must be motivated by theory, right? Where the theories that you have, you state in terms of hypothesis. I give you a very simple example. Let's say you would like to look at what is the impact of diversification on risk. Let's say you look at a bank, right? Bank obtain income from financings, but bank also obtain income from non-financing activities like trading, fees, right? And underwritings, and many other type of fees that the bank impose. So bank can diversify the source of income. And there are a lot of work that has been done in looking at what might be the impact of diversifications away from financings on the bank stability or the bank risk. So you have your dependent variable, you have your independent variables, and now you must have hypothesis, which means that the theoretical foundations. So you look at theory and you learn finance. Finance says do not put egg in one basket. You have to diversify to reduce risk. That traditional theory. But there exists also the other theory that say once you expose yourself to non-financing income, right, and non-financing income will be more volatile, and that create more risk. So the theory give you basically the not clear answers whether the impact positive or negative, and that's why you want to do empirical analysis. Okay, we do not know for sure positive or negative. Data will tell us. So you must have that theoretical foundations to underline your hypothesis. You have to remember the fact that writing paper for journal or for your thesis, right? You cannot just take, okay, I have Y, I have X, I just want to look at, but I do not know the theory. No, it cannot be done in that way. You have to know the theoretical foundations behind that. You have to know the past studies that has been done, right? And from the past studies, you think that the answer is not so clear, and that's why you would like to do research and try to clarify more on the relationship between the variable. So that hypothesis that we need. And normally I spend a lot of time, but due to time constraints, I will not explain much in terms of hypothesis, because I would say this step of having clear hypothesis and having clear motivation in terms of theories behind the hypothesis and in terms of past studies are highly crucial, right? Because you don't do research without hypothesis. Right? You start research because you have query, and that query that you have, you put in terms of hypothesis. Right? But the more important, when you have hypothesis, you have to go to the next step. Always in any model, you learn econometric 101, linear regression or whatever, they will tell you you have to have model specifications, and then you have to decide on the estimation methods. And once you decide on estimation method, you get the result. You have to evaluate your result first. Your modeling, you have to evaluate first. And after you are happy with the evaluations that you have done, then you can go to next step, hypothesis testing. You start with hypothesis, you end with hypothesis testing, and from that hypothesis testing, you interpret your results. So those have always must be, those must be the step that you have to go through. Right? You look at classical regressions. You have hypothesis, you specify linear regressions, and then you estimate using least square regressions, and you check all diagnostic, you check for heteroscedasticity, you check for autocorrelation, you check for all those things. After you are happy, then you test the hypothesis, right? Which means running the t-test and then come up with conclusions. So those are normal steps from very basic econometric modeling to the most advanced. Right? And you have this in mind, you will not be lost in terms of performing econometric analysis. Right? So I will go through in terms of model specification with respect to dynamic panels, and then I will discuss model estimations, and then I will look into diagnostic tests, all those three. And of course, hypothesis testing, you go back to the testing of whatever you have estimated related to your hypothesis before you make interpretations. So when it comes to model specifications on the next slide, right? Now, if you look at model specifications, quite simple, right? In terms of dynamic panels. When we say dynamic panel, you are dealing with panel data. I think I listened to 3 colloquiums by your friends yesterday. All of them use panel data. So I don't think I have to explain what panel data is, right? Because you have panel across the units over times. I think she have provinces for 8 years, right? And then you have countries, right? Sulaiman's on the climate change for many years, right? So everyone have that type of panels, right? And I think the thesis also you have panels. So everyone have panels. So I don't have to explain what panel is, right? So when it comes to panel data, for example, dynamic panel is very simple extensions of static panel. And how they extend by adding, if you look at lag dependent variable t minus 1, right? You extend by putting lag dependent variables. So these are model specifications. Now, when we have model specifications, you have to answer all these four, right? Whether you want to adopt this type of modeling or not in your work. The first one, why you need to put dynamic in there, right? Why you need to put this lag dependent variable in your regressions? What's the reasons? You have to answer that part, right? Because these are model specifications to capture the theoretical behavior of your YIT, your dependent variables, right? And these inclusions of lag dependent variables must be not by the method that you want to use to estimate, but by the theoretical foundations. Because based on your arguments, you think that the current value of YIT also depends on the past value. So you have theory behind it, why it depends on past value, right? For example, very simple examples, right? Our consumptions, right? Our consumptions, the way that we plan our spending from month to month, it depends on what we spent last month, right? Why? Because we have habit, and habit is persistence. When you see that consumption have that persistent habit, it means there exists dynamic. So you must have that type of explanation why you want to use dynamic, right? Some of you to look at bank non-performing loans, for example. And non-performing loans is not something that just happened. It depends on the behavior of the bank in the past. So it will depend also on the riskiness of your lending in the past. So there exists dependence, right? So you must have that type of reasons. And mostly if you read articles, sometimes they do not say the reasons. I use dynamic panel, but underlying it, there exists that theoretical foundation, because sometimes the article do not give you the reason because it becomes standard practices, right? Standard practices means that when people, let's say, model the lending behavior, they have dynamic. When people model investment behavior, they have dynamic. So it becomes standard practices. But underlying it, you have to understand the existing theoretical foundations, right? So you have to be able to understand why dynamic, right? Why you want to, if you don't have reason to believe that there exists dynamic, you just go back to static panel or traditional panel, right? If there's no strong reasons to believe that. But if there exist strong reasons, either you have your theoretical arguments or standard practices in the literature. You read a lot of articles in that topics. Out of 20 articles, 15 of them, majority of them use dynamic panel. So you use dynamic panel, right? Kind of along the line of practices. But better yet, if you get the theoretical foundations, right? That why the dependent variable depends on the past value. And this capture theta here capture what we term as persistence, right? The value persistent mean that it depends on past value, right? So that's what you have to look at. Now, the second thing that you have to ask yourself, what must be included in the variable x? These are something that also bother us a lot, because when we read the literature, we do not get the guidance. We see a lot of things that are included in our independent variables, right? I think you see in your case, you read a lot. She wrote on economic growth, and economic growth depends on so many different things when you read, right? So you have to decide what needs to be included. And of course, the one that needs to be included is basically the key independent variable of your interest, right? You have to look at the key independent of your interest, right? And that one, of course, must be included because that's your hypothesis that you want to test. Right? That hypothesis you want to test. I think I just give the examples that I listened yesterday. For example, Sulaiman want to look at how climate change affect food security. So climate change must be included as part of the independent variables, right? And in your case, you want to look at the multilateral debt, how it affects economic growth. Multilateral debt must be included because that are key independent variables, right? And the same thing for you, fintech and financial inclusions, how it affects poverty. Those two must be included, right? But then apart from those two, you have to think of other variables to be included as control variables, right? And that becomes the problem. How many of them? Right? I will try to answer at the end how we deal with some other variables to be included. But this is what needs to be decided. You have to decide what to be included, what is enough and enough. Now, being a researcher, you have to understand this, right? And many of you are doing PhD, for examples. Always when people try to examine you, they will attack you. They will ask you, why you include this? Why you do not include this, for example. So you must be ready to defend, for examples. And the best way to defend, I will inform at the end how to defend, to include or not to include the variables. Right? How is our strategy? What is the right model? We do not know for sure because the world is so complicated. We just use linear equation to capture things. Right? So we may not be right and no one will be right, but then at least we have reasoning behind what we are doing. And that what we term as defense or viva, right? You defend what you are doing. Right? And you must have reasons behind it. And of course, the best defense would be, these are common practices, people include these variables. But better yet, you have your own strategy in terms of deciding what value that need to be included in X, right? And look at here, what are deemed relevant, maybe based on theories, maybe based on past studies, right? I think, sorry to use a lot of your examples, because you look at economic growth, the theory is solo growth models or neoclassical growth. Of course, you have to include saving and populations. Yeah. Yeah. But then you have the basic theories, which means you include those because of theoretical foundations. And that one really important part. You have the theoretical, and in that way, you can make a sound arguments why you put all those variables in. But you have to decide. And being researchers, you have to make your own judgments. Right? You cannot say, because my supervisors asked. No. That's not the answer in the Viva. You have to make your own answer. I include this one because there exist theoretical foundations, and this has been considered by this and this and this, for examples. Right? So those are type of things that you have to defend. You have to be ready in order to answer. The same thing when you write your article, whatever control variable you put in, you must have a brief justification, for examples, why you put that variable in. People need to understand in terms of the variable that need to be put in. And then once you put variable in, yeah.
When we test the genetic,
yeah.
It's like input data.
No, I'm coming up next later on. Right? Don't worry, just basic first. Right? That one's coming next. Now, what is the assumption about X? You have to answer. Right? And the very basic assumption that we start, X are exogenous. Easy, like any classical assumptions. When you have Y equal to beta 0 plus beta 1 X1, you make assumption X exogenous. And that's very easy to deal with. So for the moment, we make these assumptions, X are exogenous. And now we ask ourselves, what are the assumptions about the error terms? Those are specifications that you have to think. Right? And when it comes to error terms, the starting points always classical assumptions. Right? You go back, error terms are normally distributed, error terms are independent, which means there are no autocorrelations. And because you have many units, many cross-section units, error terms are not cross-sectional dependence. error terms are homoscedastic in terms of variance, right? And model specification is right. So those are classical assumptions that you put in. So these are the starting point of model specifications. And of course, when we start with this, at the end, when we want to estimate, there are a lot of things that we have to ask. And I will raise at the end, right? But the main part that I will discuss, let's say what we have done so far is right. We make argument in our thesis that, okay, the variable that we try to explain have dynamic, right? Depends on the past value. And that's why we use dynamic panel. And we make some arguments of the variable that we want to put included as independent variables. And let's say that are acceptables. People accept. Why? Because we have sound arguments. And let's say these assumptions are true, X exogenous, right? And also let's say these assumptions are true, that the error term follow classical assumptions, right? So let's say all these true. Can we estimate and how to estimate this? So even if we have all these model specifications with all these assumptions that we have made, dynamic panel models, even with those assumptions, X exogenous classical assumptions, dynamic panel model have the problem of endogeneity, which is the next slide that I put in, right? So when you specify the model as dynamic panels with the assumption that we have discussed before, there exists basically one key statistical issue in dynamic panel models, right? Even with those classical assumptions, there exists one. And that issue is endogeneity, right? That's the problem, and I would say very big problem that we face, right? In dynamic panel model, right? X exogenous error term have classical assumptions, but dynamic panel model have endogeneity problem. And when we say endogeneity is what? In general term, right? In endogeneity, when there exist correlations between the error terms and the independent variable, the right-hand side variables. With any, at least one, right? With that variable, we have endogeneity problems, right? So that's what we mean by endogeneity. Now, in dynamic panel models, the reasons of or the source of endogeneity, X is exogenous, so the source is not coming from here. But endogeneity coming from the correlation between this and the error term. And that endogeneity in dynamic panel models. You cannot make assumption that dynamic panel model doesn't have endogeneity problem, because endogeneity is part of dynamic panel models. It's part in there. It's the result of your model specifications. Because yit minus 1 will be correlated with the individual specific effect mu I. Right? Now, very simple to look at this, right? If you write, for examples, right? Puts like this. Now, if people ask you to explain, how do you know endogeneity? You write yit equal to the way I write it, theta yit minus 1 plus I think put delta xit, right? And then plus individual specific term and plus vit, the standard error term. And if I write my equations yit minus 1, this one will be equal to theta yit minus 2 plus delta xit minus 1 plus mu I plus vit. And you look at this individual specific effects is determinants of this. And that's why these two are correlated. Simple, right? Because the individual specific effect is a component in yit minus 1. Right? Because we make this to be equal. So this one component of this. So that's why these two are correlated. And when these two are correlated, we have endogeneity problem. And that's the main source of endogeneity. Even if we have all the assumptions are right that we have made. When you have dynamic panel models, remember endogeneity coming from yit minus 1 and this. They are correlated. Right? So what would be the problem of these correlations? Right? If I ask you for examples, right? When you do traditional panel models, right, without we can ask the new doctor when you have very static panel model that you have like this, for example, let's say there's no dynamic, right? If there exists correlation between x and the error term, right? What estimation that you use? Or if the error term is this, let's say error term is follow the classical, but if there exists correlation between these two, when there exists correlation, which means we have endogeneity in X, for example, in normal static panel. You test this. Remember, you use if you learn Osman test, right? Osman test is to test whether there exists correlation between X and this or not. And if there exists correlation between those two, yes, you use fixed effect, right? And if you said no, then you use random effects, right? But you have to remember, both of them are biased in small samples, right? But fixed effects better than random effect because fixed effect is consistent. What do you mean by consistent? Consistent means that the estimate that you get are unbiased when the sample become large or approaching infinity. So it becomes asymptotic theory of econometrics, right? So that's why we use fixed effects. So the same thing if you have dynamic panel model, if you apply fixed effect or random effect with limited sample, you get biased estimates, right? So that's why fixed effect and random effect, we never advise to use them. Right? Yep.
How much?
You see, consistent means that when your n, your t go to infinity, and your sample is finite, right? Now, sometimes I do not want to go to more theory, because the fixed effects, right? Random effect for sure you cannot use. It's biased from the beginning. But fixed effect is basically the bias will drops as t increase. So which means that if you have a long time spans, right? I think some study has been done. If you're trying to find the article, theoretical article by Nichols, they call Nickel bias. Right? Nickel bias, and later on written by Owens and some other studies has been done. They have shown that if T increase, let's say up until 30 or 40, the bias become minimal. Right? But in dynamic panel, normally the T is 10 or 15, not more. And you have 8 years, right? Not more. Right? But you have long years like you, for example, that's why fixed effect still can be okay, because as T increase, the bias drop, right? And there are theoretical articles that wrote on that, right? So that's why even dynamic panel don't rule out the fixed effects. Look at your T. If T is long, you still can use them as alternative type of estimations, and that's why I think when you read article, right? When you read article, try to pay more attention to see the authors whether they use fixed effect for dynamic panel or not. You see some they use fixed effect still. Right? Why? Because of that argument that if T is large, the bias is minimal. Now, the objective of estimation, you have to know exactly. The objective of estimation is to get the estimates that are best linear unbiased. Right? You go back to the classical regressions, right? You want to get best means that the estimate have the least margin of error, which means you have small standard errors. Right? Small standard errors. As compared to many other estimators, these are the smallest. And that's what we term as best estimator. And then you want to get unbiased. So those are any estimation technique, these are the objective. If you can ensure that the way you implement them, right, if you can convince what you get are best unbiased, then your result will be accepted and will be convincing. And you yourself will be convinced with your result because the way you do is the right way, because whatever you do, you get unbiased estimates. And that's one really important part of the estimations. Right? So coming back here in terms of dynamic panel models, we have endogeneity here. Right? So, with this basic assumption that we have made, X exogenous error term follow the standard classical assumptions, but because we have dynamic panel, we have endogeneity problem. Why? Because YIT minus 1 correlated with the individual specific effects. The next thing that we have to ask, how then to estimate? We cannot use least square estimation like fixed effect or random effect, because these two will be biased in small sample, where in dynamic panel, normally T are smalls. 10 or 15 or 20, for example, very small. So the questions that we have to answer next, how to estimate, right? So that's why model specification let you to understand the reason behind your model specifications and what are the statistical problems in there. And once you understand those, then you can decide on the estimations, right? So in any analysis, estimation method come after model specifications, right? Not model specifications before specifications. So you have to understand those. Because most of the time people do this. I want to use GMM, right? Why? Because these are advanced techniques. Right? I want to use this. And then you specify the model so that GMM can be used. And that's not the right sequence.
But how about if you just want to avoid complication at the end?
No.
Because you know GMM going to do it anyway.
Yeah, I know GMM going to do it anyway, but then the way you present have to be through this sequence, specification first. You don't tell people I want to use GMM. And then because I want to use GMM, I use dynamic panel, but you don't know why dynamic panel in the first place. Yeah. So of course, when you do, you try to explain with many different type of things, but then the way you narrate the story of what you have done, you have to follow this sequence specifications first, right? Your research objective first, right? And that's why, for example, I told Sulaiman yesterday, what are your objectives? He said, I would like to look at the interactions, whether climate change affects food security, whether food security affect the other parts, right? And whether food security affect financing, whether financing affect this. So you want to look at cause and effect of many different things. So if that's your objective, your model specification must be system of equations, not just one equations, right? Have to be system of equations. So your objective give rise to specifications. And now once you have specifications, you know the issues in specifications, come estimations. So you decide estimations after you have specified. The same thing when you have this, you specify, right? Which one in static panel, which one you want to use to estimate. Right? You don't decide first and then specify. You specify first and you decide how to estimate. And in traditional panel or static panel, really easy. You have to decide on basically correlation between these two. Right? Whether you want to use fixed effect or random effects, or whether this individual specific effect is common or not, that you can use pool or LS, for example. So you decide on that basis. Okay? But in dynamic panels, because of this endogeneity, what you have to do, you have to decide. And endogeneity problems, the best way, right, or the standard way to deal with endogeneity problem is to use what we term as instrumental variables. Right? In any problem that have endogeneity, normally we use instrumental variable techniques, right, in order to estimate. And there exist so many instrumental variables estimation techniques. You have instrumental variable technique, you have two-stage least square, right, and many others that require you to use instruments. Now, the idea of using instruments is this, like, if this variable is, right, endogenous, as what we have identified here, for examples, then can we use other variable as a proxy of this or instrument of this? Let's say I call this one as Z. Can I use this in place of this so that I can remove the source of endogeneity, because endogeneity comes from here and here. So you need to get one more variable as proxy, right? So if we have endogeneity, or even X have endogeneity, can you use this in place of the X that is endogenous? The requirement's really easy. Whatever you use as instruments must be correlated with the variable that you want to instruments. But it cannot be correlated with their term. And that's the criteria for, in the next I put in slide, the criteria for instrument that need to be chosen.